Yeah, thank you so much, everyone. Welcome. I mean, Simon did an amazing job introducing me, way better than I could have, introduced myself. But yeah, hello, I'm Sabrina Smai. I am a program manager, so product manager at Microsoft in the AI frameworks team. And our team primarily works on open source projects like PyTorch and Onyx Runtime. So my particular focus is on, as you can see, PyTorch Profiler. That's the product that I currently own at Microsoft, as well as Onyx Runtime Inferencing, which is another partnership with Facebook that we have in the open source projects that we work on. So yeah, I love this community. I've been an attendee of the Azure Summit for many years, and so it's super exciting to actually be a part of this community again, and meeting some familiar faces like Simon and a few others that I see here. And so far the presentations have been amazing. So I'm really looking forward to presenting for you guys. So yeah, so in this presentation, as you can see, I will be talking about PyTorch Profiler, and then demoing it, talk about some of the integrations, and quickly go through that in the next 25 minutes. So let's just dive right into this. Okay, so imagine let's just say you are a performance engineer at a company, okay? And your job is to help identify any sort of potential bottlenecks that occur in your system, and it could be a deep learning system or a machine learning system. And your job is to also understand if there's any scalability issues that may occur before you deploy a finished product. So typically, this is how your day will start. As you can see here on the slide. You'll begin by running your deep learning model, and then you'll capture some traces along the way. And then in order for you as a performance engineer to optimize your deep learning model, you need to gather the profiling results and then analyze them. But the problem is that these traces can be gigabytes and gigabytes of data, and processing them manually can be extremely time consuming and super annoying. So once you've identified the changes that you need to make to slightly optimize it, you'll have to rerun the machine learning model, deep learning model again to check the performance. And if the performance is great, then hooray, like your job is done. You can get yourself a celebratory beer and, you're done for the day. But if that's not the case, then you'll have to go back to step one, recapture, a profile, gather the results, find out the reason for the bottlenecks in your deep learning system, try to fix it, and then start the process over and over again. And you'll have to repeat this pretty much an N number of times until your performance is satisfactory. So this is a typical day as a performance engineer. And you can imagine how extremely exhausting, tiring, and annoying, and just frustrating it can be. So here at Microsoft, we actually partnered with Facebook to bring performance engineers, data scientists, framework engineers, or anyone looking to optimize their PyTorch models, a tool to allow you to automatically process your traces, analyze them, and then provide these automated performance guidance for optimizing your machine learning model. And that tool is called PyTorch Profiler. So I'll actually go over the new release of PyTorch Profiler that came out a few months ago. And there will be a new release that's coming out in the next 2 weeks, so look out for that. But for now, we'll be covering the current release of PyTorch Profiler and how you can start leveraging this performance tool. And these are the sort of features that I'll go over. The first, and I'll quickly summarize a few of them. The first one I'll be covering is distributed training view, memory view, GPU utilization, cloud storage support, and a really cool one is a feature that's on VS Code that allows you to jump to source code, which is pretty awesome. So I'll summarize all 5 of these major features that have been released, and then I'll go through a demo. So the first major feature that was released in PyTorch Profiler is a feature called a distributed training view. So this feature helps you sort of understand, how much time and memory is being consumed in your distributed training. So oftentimes many issues occur when you take a training model, split the load into different worker nodes to be run in parallel, and sometimes what's happening in that can be a black box. And so like the overall goal of a distributed training technique is to speed up your model training. So it's going to be very difficult to diagnose your distributed training without a view like the one at PyTorch Profiler that will help you diagnose and debug issues within individual nodes. That's the key that makes this tool pretty awesome, is that I'm so sorry. Someone's passing by with really loud music. I'm really sorry. So the main feature about this is that you can diagnose issues within individual nodes. So the next feature that was released in this, I'm really sorry, someone just passed by my window with some really loud music. The next feature is memory view. That's the second feature that was released in PyTorch Profiler. And this view allows you to understand your memory usage better in your model. So this tool can help you avoid the very famously pesky, and I'm sure, Simon, you can attest to this, the very famous out-of-memory error that we all sort of experience when you're running, your machine learning, deep learning code. And so this memory view allows you to avoid these errors that relate to memory by showing you the active memory allocations at various parts of your program run, which is quite useful. The third feature that had been released in this PyTorch Profiler release is a tool called GPU utilization. And this is a tool that helps you sort of make sure that your GPU is being fully utilized. And this is really important because having close to 100% utilization of your GPU basically means that you're using your hardware to its full extent and you're not leaving any performance on the table. Oftentimes, you'll see that if you run a GPU utilization tool like this, you'll see that your GPU utilization is around 20%. And that just means that you're leaving 80% of the performance on the table and you're not fully using your hardware to its full extent, which is not great. The fourth feature that was released in PyTorch Profiler is called cloud storage support. So there's a TensorBoard plugin for our PyTorch Profiler, and you can now officially read profiling data from, blob storage, Amazon S3, and if you're using Google Cloud Platform, that's something that you can definitely read your profiling data from, which is quite useful. And then the last feature that had been released in PyTorch Profiler is something called jump to source code, and this is personally one of my favorites tools, and this is a feature that allows you to visualize your stack tracing information on TensorBoard. So let's just say you have a list of stack tracing information, and if you were to click on one of the stack traces, it will jump directly into your source code where the bug is. So this is really helpful when you're trying to quickly optimize, iterate through your code based on that profiling data results. And I'll actually show you a quick little video of how this jump to source code feature works. So this is TensorBoard. And you're able to see that there's a list of stack tracing information here. And if I were to click on one of the stack traces, it jumped directly into the source code in Visual Studio Code of where the bug was. So now I know exactly where, how to optimize my code based on the stack tracing information that I got, which is quite useful. Oops. So how do I get started? The first is doing a pip install of, this is something that I would encourage many of you to try out. Just on VS Code, do a pip install of Torch TV Profiler, and then you're able to try out these 5 features on how to optimize your PyTorch models to be able to visualize some of the memory allocation, some of the GPU utilization. Just doing a simple pip install today, you'll be able to see if you're using your GPU, utilizing your GPU to its full extent, or are you leaving, performance on the table. So you'll also need to import your, as you can see on the code on the right, you also need to import the Torch profiler in your code. And then the third sort of step, and again, this is pretty easy to use PyTorch Profiler, you'll need to set up the Torch Profiler context. And this is where you'll be turning on what you want. You'll be turning on whether you want GPU profiling, whether you want whether you're doing distributed training view and you want to diagnose individual nodes. And that's where you're setting the context in this context manager area here. And then the last sort of step is in your for loop, where you're actually doing the training run, you can actually call this p.step for the profiler step. And this is where it will collect all the inputs, and then the traces will be pretty much ready, and then the output function will be called. And so the traces will be saved in a Chrome trace file, and then you'll be able to visualize them in TensorBoard, the TensorBoard plugin that I had showed initially. So let's actually switch over to a quick little demo. Let's see. Oops. Switch over to a quick little demo to show you how how this PyTorch profiler works. So the first feature that I'll go over is this memory view. And memory view is, like I said, an added feature in this release that allows you to understand the time and memory consumption that you have that may cause bottlenecks in your code. So an example is an error that I had mentioned, out of memory error, which is an issue. And so this memory view over here essentially allows you to see which operator exactly by the name is contributing to your high consumption of time and memory. And you can toggle between GPU or CPU. And you can see how many times this operator was called, the size and some of the allocation counts. There's a lot of information, and you'll be able to see if one is really high in time and memory, then perhaps reviewing that operator and try to optimize it will be the way that to help with that bottleneck. The other feature, the next feature that I'll show is the distributed training. So this is actually, so perhaps let's just say, speeding up your model training is your goal. So you conduct something called distributed training. So, but many of you already know that debugging can be really complex and really hard to diagnose without a distributed training view like this. So you can observe issues actually on individual nodes. So you can see some of the information on each node, and each of these views that you can see here provide you all different types of information that can help you diagnose the reason for your bottlenecks. So let's just say that for example, this view over here, this computation and communication overview, if I were to look at this and I were to observe the overlapping time of if one overlapping time of one worker is larger than the other, as you can see here in the right, there's a huge deviance, then perhaps this may suggest that there's a workload that's not being balanced, or one of the workers is being a straggler, like potentially this worker is being a straggler, which is an issue that needs to be corrected in your code. And so these are all different types of information you can get. Below, there's actually a communication operations statistics, which is a table that allows you to see some detailed statistics on all the communication operations in each node. So this will allow you to see, what type of operator is being called, how many times it's being called, what is the size of data being transferred by each operator, which is quite useful information actually when you're doing distributed training. So sometimes performance issues are beyond memory and beyond node level issues in your model. And perhaps you need to observe issues on the GPU level at each step. So this is where the GPU utilization sort of comes in, okay? So as you can see here, there's 3 metrics that are important for GPU utilization, SM efficiency, this estimated achieved occupancy. And you can see that the results here, the summary of the GPUs are quite low. They're like around 22 to 33%, which is quite low because, like I said, GPU utilization, the goal is to try to get as close to 100% as possible. So if you were to, run a ResNet 50 model, with batch size of 4, which is this is the run. Imagine you're running a ResNet 50 with batch size 4, and this is the results that you get. Obviously, that's quite low, and there is a bottleneck. So and there's many reasons for potentially why the GPU utilization is low, and I can get into that later if you guys are interested. But there's clearly a bottleneck. So down here, if you scroll down, there's actually some section called performance recommendation. This PyTorch Profiler was able to identify that the GPU utilization is low. And then it provides a performance recommendation to increase your batch size to improve your GPU utilization. So this is an automatic performance recommender just based on your results of your ResNet 50 batch size 4. So I will go ahead, and the next run that I will do is run my ResNet 50 model with batch size 32. And then you can see that my GPU utilization increased drastically, which is great, which is quite awesome. But it's still not as close to 100% as I would have liked. So to further diagnose, there is actually a view, this trace view. I will go back to this ResNet batch size 4, and there's something called trace view, which will allow you to see the overall utilization view in a 10 millisecond buckets. So you can see this is the GPU utilization here in the blue. And so yeah, you can see that the GPU utilization in the blue, and we were to observe sort of the overall trends here, and you can see that over here there's actually an unusual dip. So what we can do is actually zoom in a little bit, because like I said, these are 10 millisecond buckets, and we'll be able to observe things a little bit further. So the GPU utilization, if I were to click over here, it shows that my GPU utilization is actually at 11%. And then over here, if I were to click over here, it's actually at 50%. So, obviously something must have happened. And then so, let's look at the SM efficiency over here, this pink section over here, to investigate a little bit more, because the SM efficiency metric actually gives us finer level details on each kernel. So by observing this SM efficiency, I can kind of conclude here that you can see that the reason for the low utilization, GPU utilization, is because of how sparse it is compared to the other areas, how sparse, and some of the idle time between the kernels that is possibly, contributing to this low GPU utilization, which is obviously, an issue. So as you can see, I'll actually switch back to the slides here, but as you can see, sometimes performance issues can be a black box, and then having this new release of these features, these 5 features that that help you diagnose and optimize your code, really make it easier for your PyTorch model, which is really helpful. I'll actually quickly talk about some of the integrations that we have. How PyTorch Profiler, we actually did integrations with PyTorch Lightning. If you're familiar, And so, you'll be able to, just with a single step to call from the PyTorch Lightning, you'll be able to get all the traces by default. We actually also integrated with Kubeflow, which is actually quite amazing. This is actually an end-to-end integration of a BERT model. And this is a view. You can see that in your pipeline, in your Kubeflow, you can actually jump directly from there to the tensor board, where the profiler is on the right side in the same exact pipeline view, which is really, really awesome. And then these are a few of the upcoming features that my team at Microsoft, as well as Facebook, is looking forward to, commit to in the next, this is just kind of a sneak peek of some of the features that will be released in the next release, as well as down the line. And we're actually really excited about some of them. We'll have some graph utilization, visualization. We'll have an enhanced version of the kernel and memory view, which is great. We're going to have a little bit deeper recommendations, those automated performance recommendations. We'll actually have tensor core. We'll also have glue support, which is actually great for the distributed training. And then also we have an RFC for this diff trace view, so you'll be able to see different runs side by side and see some of the differences there. And then down the road, here are a few just like sneak peek of some things that we're looking into down the road. Some module view level views, some enhanced support for profiling, especially on the distributed training job, because we hear data scientists struggling with that, and we want to help reduce the bottlenecks, especially in the distributed training. And then we're hoping to also down the line have some integrations with Azure Machine Learning, and some more hardware support. So these are the things down the line to look forward to. And then this is just kind of to wrap up. I know that there's quite a few of you that are might be interested in trying it out. And like I said, doing a pip install of TorchTB Profiler. I would love to hear what you guys think. I mean, if you try it out and you have some feedback, I would love if you were to email me, let me know what you think. If there's any sort of issues, there is on the GitHub PyTorch/Kineto. That's where you can file an issue if there's any issues that you feel like that need to be addressed. But other than that, there's a lot of tutorials online, and we're coming out with a lot more materials and trying to help evangelize this PyTorch Profiler a lot more. There's quite a few people internally at Microsoft, as well as other folks, other Fortune 500 companies that are using it for their PyTorch models. And so I'm really, really excited to see if you guys try it out. Let me know what you guys think. Just doing a pip install of TorchTB Profiler. Feel free to just try it out on VS Code and then see how it's integrated in VS Code. It's actually quite interesting. We have a lot of resources, and yep. So I think that concludes my presentation. Here's a few resources actually on PyTorch Profiler, as well as some of the integrations and talks we've done. But other than that, I think this concludes my presentation.